Taylor now has a JavaScript backend, which means that you don't need an Ethereum chain to interpret Taylor in the process of writing code. The chain acts as a computational standard to which Taylor interpreters in other languages must conform. The JavaScript backend is written in the same language that is interpreted by the chain and implements the native EVM and Taylor functions that are the core of the system. When you go to the Taylor editor, now you see options to run the code on the JavaScript backend, the Web3 injected provider for Ropsten, Covangoli, and Ringby, and on both. When you run on both, you will see a green circle if both backends give the same result, and a red circle when the results differ. The results must be the same. We have to achieve perfect emulation, but in the current development phase they might differ if the persisted user-defined functions are different for each backend. Now let's try out the examples from the README page. And we get the same result, 47. Let's see if the lists work, and they work. If statements and lambdas also work. Now for the def function. The def function stores the function definition so we can use it later. Now note that while the JavaScript backend already stored this definition, if you want to also save it on-chain, you will need to click on this run button. But let's see how we can use this function. And we get the result 10 from the JavaScript backend, but because the function is not stored on the chain, we get a red circle. Now we have a Fibonacci series function that is already stored on-chain but is not defined in the JavaScript backend. So what we are going to do is just paste the definition here and now use that function again, and we have a green circle once again. And we can also use this in a higher order function. And we get the same result. Let us know what you are able to define using Taylor, and save anything of consequence on Ropsten.